This video will present Task 3.4 of Work Package 3 of the TENSOR project, with title, Responsible and Explainable AI for Fair and Unbiased Biometric Technologies, and the progress during the first periodic report. The task is led by SQD. The main challenges that we would like to address within this task are divided into fairness and explainability. As far as fairness is concerned, we propose an analysis on the biometric modules that are developed in Work Package 3. AI models in general are prone to learning patterns that are present in their training datasets. Should these datasets be unfair, the produced AI models will be discriminatory and maintain existing inequalities. On the other hand, explainable AI includes techniques to get an insight on the decision-making process of an AI model. Since AI solutions have become part of critical processes like criminal justice, getting a direction on the mechanics of these models can build trust around them. In our fairness analysis, we've delved into the demographics that AI biometric models may introduce bias. For instance, with face recognition, we are particularly focusing on age, gender, and skin color. To address this, we plan to recommend datasets annotated to include these demographics. Work Package 3 partners will then inference their models to these datasets, allowing us to thoroughly evaluate the results. This approach aims to ensure that biometric models are fair, steering clear of any preconceived biases. In the realm of explainability, we're implementing XAI algorithms, especially those producing visual results, onto the biometric models. This move enables TENSOR's users to gain insights into the key features influencing the matching process, providing a transparent understanding of the model's decision-making. This step reinforces accountability and comprehension in the deployment of biometric technologies. Regarding the functionalities of our technologies and the novelties that are introduced, recognizing a gap in research, we've undertaken an extensive research resulting in a customized solution for the modules that will be used both in relation to explainability as well as the fairness and bias analysis. Our proposal includes GradCam for computer vision models, generating heat maps that illuminate critical features that were used for the matching of the individual's gaits with those in the suspect's database. Lime and SHAP are open-source libraries for explaining the decisions of machine learning models, regardless of their complexity or the algorithm used. This makes them versatile tools for explainable AI. Thus, they will be applied to the biometric modules, in order to decode the significance of input features in tabular data models, enhancing interpretability. The diagram shows the main workflow of the SHI pipeline. Our inference pipeline hinges on two critical components. First of all, we leverage the raw input from the modules developed under Work Package 3, capturing the details of each scenario. Then, we utilize the model itself and we forward it to the XAI model. For instance, in the gait recognition module, we use extracted poses as input along with the gait mixer checkpoint. Gait Mixer is a state-of-the-art algorithm that takes as input the human pose in a sequence of 60 frames and produces distinctive features of an examined individual. The aforementioned checkpoint is the model itself, and it is necessary for the explainability of the module. Addressing fairness and bias, we've conducted analyses using datasets like fair face and fair voice. Fair face ensures balanced representation across race, gender, and age in face attribute datasets, while fair voice diversifies similar utterances, along with spoken language. We provided the datasets to the corresponding partners, and they inferenced their models on these datasets. The results were then handed to us for evaluation of fairness and bias. Explainable AI generates visual outputs such as images or heat maps, revealing insights into decision-making. User-friendly text explanations further break down the AI's rationale, like focusing on specific joints for gait recognition. In terms of fairness, we deliver a statistical analysis and charts assessing accuracy metrics across demographics like age, gender, skin color, and language. This commitment to transparency helps identify and address potential biases, ensuring equitable AI decisions. An example output with respect to the application of SHI to the gait recognition module can be seen in the attached figure. The x-axis represents frames 1 to 60, and y-axis represents 17 joints. Features with higher contributions have higher heat temperatures. That means that the joints that are circled in the displayed figure were more important in the production of a distinctive feature representation of the examined individual. TENSOR's face and voice recognition module undergoes rigorous fairness and bias analysis to ensure reliability. Simultaneously, the gait recognition module incorporates explainable AI for transparency. The commitment to fairness is not only about meeting ethical standards, but also about delivering accountability. XAI empowers both the gait recognition provider for system refinement and end users for a clear understanding of TENSOR's decision-making process. By integrating fairness analysis and XAI, we are not just advancing technology, we are shaping a more ethical and transparent digital future. The results that are produced by the biometric module trigger the XAI pipeline. After the pipeline is executed, the TENSOR user will be able to see both the result from the matching and the features that led to the corresponding matching score. In parallel, there will be information regarding the fairness and bias assessment of the biometric module, so that they are aware of the model's reliability. Similar to use case 1, in this scenario, XAI provides essential explainability information to both the providers of gait and behavioral recognition and the end users. For the providers, XAI becomes a valuable debugging tool, offering insights to enhance the robustness of their solutions and streamline development. Simultaneously, end users benefit from transparency in decision-making. XAI allows them to comprehend the intricacies of the TENSOR platform's decision processes, fostering trust and enabling informed interpretations. This is a short demo that showcases the two main axes of responsible and explainable AI. Using a Python framework called Streamlit, we create an interactive app, in order to show some basic functionality of our solution. As far as fairness is concerned, we shared the Fair Voice dataset that is mentioned in the previous slides to Phonexia. Phonexia, which is the responsible WP3 partner for the voice recognition module, evaluated their model using this dataset and shared the inference results. CLLR is a metric that includes both error rate and information loss between speech input and decisions. For better performance, we prefer to have lower CLLR values. The plot shows the performance of each demographic, and it will be available on the TENSOR dashboard. In the second page of this demo, we have presented the desired results for the gait recognition module. On the left, we see the extracted poses of an individual for a sequence of frames, and on the right the desired output of the GradCam solution. The joints that are highlighted played a more significant role in the feature representation of gait mixer. Thank you very much.